Hello, good afternoon. Today is a little bit different because Dr. Matt Helmers is in the hot seat, and I am Jacqueline Comito, and I am your guest host for the Iowa Learning Farms webinar. Today, this is a great talk we have. Okay,
just a second. We got somebody that's
Yep.
Let me check here. If you
I just did muted all, except that meant I muted you, Matt. Unmute yourself. Okay, Matt, you there?
I'm here.
Okay, so back to my introduction after we had that. Welcome. Today we have a really good webinar for you with Dr. Matt Helmers, Director of the Iowa Nutrient Research Center and longtime faculty advisor for the Iowa Learning Farms. It's great to have Matt talk about some of the work he's been doing on his plots, as well as this project we have called the Conservation Learning Lab. So, Matt, you're so big, you don't need any more introduction. So I'm just going to hand it over to you.
Don't need any more introductions, Jackie and Dr. Comito. And I would say that I like it better when I am the host and not the individual that is giving the talk. But I am excited to talk a little bit about this, about some of the work that we've been doing, looking at cover crops and the impact on nitrate-N loss. I will preface it by saying some of this is definitely a work in progress. And so especially as we get to some of the watershed scale work, and there's still a lot of work to do there on some of the statistical analysis and so forth. But I think it's at a reasonable place to at least talk about it. Those that might have been on webinars in the past have shared some of it before. So it'll be a continuation of that. I'm going to first talk about some of the work that we've been doing going back since 2010 at our Gilmore City Drainage Research Facility in Pocahontas County, Iowa. That is a site that was established in 1988 and 89 and continuing to do drainage water quality work at that site since that point in time, primarily funded by the Iowa Department of Agriculture and Land Stewardship. And so we've been able to implement some cover crop treatments up there, and just wanted to highlight those again, and I think also illustrate the importance of long-term monitoring and the importance of, if we just look at a snapshot in time, we might not see some of the impacts that we would expect. And I think that feeds into talking about these things at the watershed scale as well. So those that have heard me talk, this is definitely a repeat if you've heard me talk about drainage water quality plots, but this is the way we monitor most of our drainage water quality sites. The plot size differs at our different sites throughout the state, or different sites that others at Iowa State University are monitoring, but the monitoring systems are really set up similarly. We have an individual treatment plot at our Gilmore City site. That plot is 50 feet wide and 125 foot long. We route the drainage water from the center tile line below each of the plots to a sump. There's a perforated border line that goes to the main drainage system. And that is to try to isolate one plot from the next and isolate treatments. Okay, how we monitor that is that water from the individual tile line dumps into a sump, like you might find in the basement of your home if you live in Iowa and have a sump pump. Then we just have a sump pump in there, and that pumps the water out. We have a flow meter that we can calculate, or that we use to accumulate how much flow has come out of that individual plot. And then we have an orifice in line, and the back pressure in the pipe will actually force a small flow proportional amount of water through that orifice, through the tubing, into the sample jar. So with that, we're able to get a flow proportional water sample of the water that's come out of that drainage plot. Okay, so let's look at some of the impacts. So for the last, since really 2010, we've had a system implemented there where we had some tillage and then tillage with a rye cover crop. And in this, in the first 5 years, that tillage was in the fall, and then we would drill seed the winter cereal rye cover crop. The second 5 years, from 2016 to 2020, it was interseeded cover crop about Labor Day, and then it was burned down in the spring and then tilled right before planting. And what we saw in this is throughout that whole 10-year period, we saw about 110 pounds of nitrogen reduction, or nitrate nitrogen reduction. So that over that 10-year period, about on average 11 pound per year reduction in nitrate nitrogen that would have been lost to our drainage system. So it was very effective in both of those 5-year periods. Okay, now a lot of times when we have cover crops, we might use a no-till system. And so in 2010, we implemented no-till at this site. And so I should have said that each of these dots or symbols on there is the combined nitrate nitrogen loss from a corn soybean cropping system. So there were 4 plots in corn and 4 plots in soybean in any given year. And we grew the winter cereal rye cover crop before both corn and soybeans. Okay, so in 2010, we switched these plots, these no-till and no-till cover crop plots. So those would be 16 plots, switched from a more conservation tillage or conventional tillage system to no-till. So this first 5-year period is really the kind of the first 5 years post implementation of no-till. And then the second 5 years is the second 5 years of no-till implementation. And this is what's kind of interesting, we thought, was that we did see, I'm not showing it here, but we did see some reduction in nitrate load with the no-till, which was different than what we've seen in other studies. But from the cover crop standpoint, we really didn't see any impact of the cover crop in that new no-till system in reducing the nitrate loss. However, when we look at the second 5-year period, we reduced nitrate loss almost 10 pounds per acre per year, a cumulative 46 pounds reduction in nitrate nitrogen that was lost from the drainage system where we had the no-till with the winter cereal rye cover crop. So, if we just had data from the first 5-year period, we would say, well, that cover crop really didn't do much. But we have data, fortunately here, we have data from that second 5-year period, and we do see a benefit of that cover crop. I think it's still an unknown exactly why we didn't see it in that first 5-year period, whether that was due to some of the soil biological changes in converting that system to a no-till from a more conventional till system. But again, I think it highlights that we did see benefits from the cover crops, but in this case, they were a bit delayed in when we saw those impacts. Okay, and this really acknowledged the funding of IDOLs, and then specifically during the first 5-year period, this effort was also part of the Sustainable Corn Project funded by the USDA National Institute for Food and Ag. Okay, so now we're going to talk about things a little bit more at the watershed scale. And again, I've shared a little bit of this in the past, so there's a few repeat. But Dr. Bill Crumpton does a tremendous amount of wetland monitoring, and the outlet the inlet to those wetlands is also the outlet from a watershed. And so we started looking at the potential for a couple sites where we could look at implementation of in-field management practices, specifically cover crops. We now have 8 years of monitoring data, 3 years pre-implementation of cover crops, and 5 years post. These are small, relatively small watersheds, and their selection was a bit based on anticipated participation of landowners. Okay, so in the Floyd County watershed, this is in Floyd County, there's 2 watersheds, one that we would consider our relatively controlled watershed located quite close to the watershed where cover crop or where the treatment watershed. So there's two watersheds. The watershed where I'll show you the cover crop implementation is a watershed about 541 acres. You'll see with the purple arrow points to where the points at which water and nutrients are delivered to that wetland. So Dr. Crumpton is monitoring the inflow and outflow from that wetland, but the inflow to the wetland serves as the outflow from that contributing watershed area. Okay, so 541 acres. And you can see here were the new practices implemented in the fall of 2017. So you can see most of that watershed area, greater than 50% of that watershed area is in cover crops, and then down closer to the wetland down in the lower left corner, there is some cover crops and strip till, and then there was a little bit of new CRP enrollment too. But that whole dark green area was the cover crops and strip till. Okay, so 675 total acres of cover crops. You'll notice that some of those fields extended beyond the watershed boundary. So the whole field was treated, not just the part that was in our watershed.
It's still a big benefit.
Okay, make sure we're muted. Okay, so we see about 77% of the watershed was treated with cover crops, 74 acres of strip till, and 1.7 acres of CRP. Okay, in the Story County watershed where we implemented the practices, a bit bigger watershed, 1,270 acres. Again, you can see here the point at which water and nutrients are delivered to the downstream. In that, again, cover crops and strip till. But as we look at it, about 49% of the watershed, so a lower percentage of this watershed treated with cover crops than the Floyd County watershed, but pretty large, still 781 acres of cover crops during most of these years, and 664 acres of strip till as part of this. Okay, as I mentioned, Dr. Bill Crumpton's group has been monitoring at these wetland locations for a number of years. They are instrumented so that there's automated samplers at the inflow and outflow of the wetland. Obviously, I won't talk about the wetland performance. You can go back and watch a webinar from Dr. Crumpton that highlights that. But taking daily composite samples for nitrogen, actually a suite of species of nitrogen and phosphorus. I'm going to talk about nitrate today. And then they have continuous flow measurement as well. Okay. And this just shows close-up of one of the samplers that would be located at one of these sites. And so there's, I think they take a sample every 6 hours, and that's composited into one of these bottles. So there would be 4 6-hour samples in each of those individual bottles for a daily composite water sample. So very frequent water sampling as part of this effort. Okay, so what have we seen if we compare what we would call our control watershed, where we've not had any active intervention to try to increase cover crops or other practices. And really what we find is that we have very similar water flow. So this would be the water yield, inches of water equivalent that we're measuring at the outflow from the watershed, inflow to the wetland. And you can see it, it varies from year to year. Obviously, in our Story County site, very dry in 2021, a little bit wetter in 2022, but we see very similar water yield between the two control and treatment watershed. Okay, that's good, behaving relatively similarly. Okay, so what about our nitrate nitrogen? Here we go. I'm going to show this. And so if you've watched this before, I talked about information of 3 years pre-implementation monitoring, 3 years post-implementation monitoring. So we had the 3 years, 15, 16, 17, before any cover crops went in the treatment watershed, and then subsequently 3 years post that. Okay, and as we looked at this, we really didn't see much difference between the control and treatment watershed. And really the Story County site kind of illustrates the importance of having some of that pre-implementation monitoring, because the treatment watershed was throughout pre and post implementation was lower in the flow weighted annual nitrate concentration that we saw. But what was kind of encouraging as we start to look at the last couple years is we start to see, if we look down at this is Floyd County watershed, we start to see a divergence of the flow weighted annual nitrate concentration between the control and the treatment, such that the treatment is less than the control, whereas the previous kind of 6 years, it was quite similar. And in some years, the treatment was above, some years treatment was below. But we see here in 2021 and 2022, a reduction. And I'll show you kind of if we take a proportion of the treatment divided by the control concentration. Actually, that's what this would be. So too many lines on one graph. Ann Stout is probably screaming at me from her office right now, like, why did you show this? So this is where somewhat of a work in progress. But what I took here was to divide the flow weighted annual nitrate concentration for the treatment watershed divided by the control. And so if our treatment watershed reduces that nitrate concentration compared to the control watershed, that ratio should go down. And so, as we look at our Story County site, that ratio is somewhere between about 0.57 and all the way up to 0.66. If we look at the 6 years pre-implementation and first 3 years post-implementation, and then we look at 2021 down to 0.45 and 2022 0.55. So the 2 years with the lowest ratio were 2021 and 2022. So as we move into year 4 and 5 post cover crop implementation. Likewise, and maybe even a little more striking, is we see down here on the Floyd County site. So we look at 2021, it was just a little over 0.7, 2022, just a little below 0.7 as far as that ratio between the treatment concentration and the control concentration, indicating some trend toward reducing the nitrate concentration in those treatment watersheds, which is pretty exciting. As I said, more statistical analysis, but is needed, but I'd say trending in the right way. Now, that was the nitrate nitrogen concentration. The next couple slides should be our load slides. And so this is just looking at the annual nitrate nitrogen load between the two watersheds. And if I showed you the flow back, you'll see that those years with high flow are also the years with high nitrogen load. Okay, so this again, as we start to look at these 2021 and 2022, we see that maybe some increasing distance or increasing reduction in nitrate nitrogen load from those treatment watersheds. And if I look at that fraction again, the treatment divided by the control, you can see here that both for the Story County watershed as well as the Floyd County, the 2 years with the lowest ratio are 2021 and 2022. So looking at, again, that 4 to 5 year post implementation of those cover crops. So I think, trending toward fairly encouraging for the potential with our cover crops to help us reduce with that nitrate loss at this watershed scale. Again, as I said, we definitely need some more statistical analysis, but I would say encouraging. Okay, so this has gotten me thinking, and some of us have talked about this, is what is the lag time in seeing the changes from implementing something on the field scale. So it gets me thinking about all kinds of more detailed analysis, flow analysis we can look at to try to better understand travel times. But I was able to bring up a paper that a colleague at Purdue, or colleagues at Purdue, Dr. Eileen Kladivko and Dr. Laura Bowling, published. Dr. Kladivko has done a lot of work in southern Indiana on what's called the CPAC site, Southeast Purdue Ag Center site, looking at a lot of water quality on different drain spacings. And something kind of intriguing happened there in 2005, where they killed the corn crop. And so what they saw was, because there was no corn crop and nothing to take up the nitrogen that had been applied, they saw a pretty substantial increase in nitrate concentration. And what was interesting was that occurred, it didn't come down to background levels for over a year after that happened on those plots. And it took about 15 to 20 inches of flow to get to those background conditions. So and this was at a case where it was 10-meter drain spacing, so very close drain spacing. It could still take some extended time. So if we think about it at a field scale, where we may have pattern drainage in certain parts of the field, but maybe not in others, we could be looking at greater than a year, maybe 2 or 3 years for some of that water that might have been reduced in nitrate concentration, leaving the plant root zone to finally make its way to the watershed outlet. Again, this is something that need to continue to try to think about. But I think this kind of illustrates that in some of these systems, it could take a little longer than maybe what we expect to see an impact in our drain lines from what we've implemented above it. Okay, and I just would also illustrate that one of the other factors that I think plays into this a bit is how much cover crop growth we get. And this was from a meta-analysis that was done a few years ago. We've seen some similar trends from some of our data in Iowa, but this just illustrates, if we look at the shoot biomass, how as we increase shoot biomass, get more growth of that cover crop, we see a greater reduction in the nitrate nitrogen leaching. And so, in some of those first couple years, we actually didn't get much growth in some of these fields, which probably, reduced, reduced how much reduction. That's a double negative, right? So that's very good, but it reduced the effectiveness of the cover crop. And so I think as we think about cover crops on our landscape, we need to do all we can to make sure we get effective growth there. This is a spring at our Gilmore City site. For example, we did not get much growth. We are, at least before our planting of our corn, we'll plant corn in a couple weeks, and we're going to try to let the cover crop grow a little bit. But this is a year that I might expect we see less reduction in nitrate concentration at that site with the cover crops, because our growth is quite limited. Okay, so in summary, I think that this small watershed scale has provided us a unique opportunity to examine nutrient delivery. This is the point that's being monitored, is the point at which that water and nutrients are being delivered to the stream. We've gotten nearly or greater than 50% of the 2 watersheds, the treatment watersheds, in cover crop, and I think we're, maybe starting to see some positive impact there. But as we think about this, that cover crop growth is likely to be critical to seeing the nutrient loss reductions, and so we really need to do all we can to kind of optimize or maximize the amount of biomass growth that we get in the cover crop. And I do think there's a need for some additional research on better understanding the time lag to see the impacts of some of these management practices. A lot of my prior work has been on intensively tile drained fields or plots, where we may see that response a little quicker than we see in some of these fields that may not have pattern drainage through the whole field, or the drain spacing may be a little wider in those cases as well. With that, I can do this. I'm starting them. If you're on here and you had to listen to me for this long and you need a CCA CEU, please email Elena Whitaker, ALENAW, at iastate.edu by today at 5 o'clock with your name, the name you entered to watch the webinar, and your CCA number. So Elena, ALENAW, at iastate.edu.
Okay, and you see why Dr. Helmers is the master of hosting these webinars. The next thing we need you to pay attention to is a voluntary demographic survey. We're being asked to do this as a part of Iowa State University Extension and Outreach. If you would just scan in that code, you can fill out our survey. If you've already filled this out this year, you do not need to do it again. We just need anybody who hasn't filled this out to fill it out. All right. So Matt, you got one
and
more
our
slide?
last, I'm going to plug Dr. Antonio Arenas. It's an assistant professor in the Civil Construction and Environmental Engineering Department here at Iowa State University. It's going to talk next week about mapping evapotranspiration at the field scale.
Okay, Matt, we got a ton of questions for you.
Oh boy. Okay.
Like they're coming in fast and furious, but I'm gonna not bias against the earliest question we got, which would have been your earliest slides, which were on the plots. So did you check soil organic carbon levels as you went, or just nitrate loss?
So actually, at that site, we have done some work with soil organic carbon. And actually, I would encourage you to go back and watch Morgan Davis and Emily Waring gave a webinar. Boy, it was maybe 2 years ago now, that talked about some of the soil health indicator work and also even some greenhouse gas work. In short, what we've seen is we really haven't seen a difference in soil organic carbon. We have seen an improvement in aggregate size distribution, aggregate stability. That's the one that we've seen kind of an early indicator of positive change relative to that site. And I believe we've seen it in both the no-till and the no-till with cover crop compared to the conventional tillage.
Okay. Have there been parallel modeling studies on those sites to see how they agree or to evaluate the models? And of course, you know, that's asked by a fellow modeler.
Okay, is that for the, yeah, Dr. Crystal Liu is doing work with these watersheds on nitrate modeling, and actually has some really encouraging work on that the model DLEM has performed pretty well in being able to predict the nitrate loss. And I think in the future, we'll be looking a little more at trying to understand, you know, some of these dynamics with cover crops and so forth. A lot of it's just been, you know, trying to see if the model will work and how well it will work right now.
Okay, could you speculate if you would see similar results on a non-tiled land? In other words, the direct impact on groundwater versus surface water.
So I would expect that if we have cover crops there, that we would be you know, reducing that the nitrate leaching and reducing the nitrate concentration that gets to shallow groundwater, and that then may make its way, you know, to the stream or some other underground resource. So I think cover crops is one of those practices that we can be using on the landscape, both in tiled and non-tiled fields, to help us reduce nitrate nitrogen concentration moving below the plant root zone. I would also say that it would be a practice in both of those areas that may be able to help us reduce surface runoff as well, or sediment loss and some of the soil loss at the field scale. With the variability and low amount of kind of runoff that we get at those sites, we haven't been able to tease that out, but that might be something else that you might expect where we have the cover crops, and I didn't talk about that too much.
So is there an importance of fall versus spring cover crop growth for water quality benefits?
Yeah, okay, so that's a great question, and I don't really have the data per se to directly address that, but some of our colleagues, Tom Casper and Dan Janes, did some work on their drainage water quality plots where they had oats as well as rye there. And what they saw was that on their site, they saw about a 50 to 60% nitrogen concentration reduction when they used winter cereal rye that would overwinter. So you'd have both some fall growth and spring growth. And when they had oats, it was about a 30% reduction. So that doesn't directly answer the question like for winter cereal rye, which is the most important period, but at least it, that I think we get some additional benefits by that overwintering cover crop compared to that cover crop that would be killed in the fall. And actually that's what we saw from our CIG project as well, where we had cover crops at 6 sites throughout Iowa that we saw, greater reduction in nitrate concentration in the plant root zone where we had that winter hardy cover crop.
Okay, Matt, we've got a couple different questions asking you about, did you look at phosphorus reductions?
So we've monitored phosphorus there, and we really don't see any discernible trend there.
Backyard.
Just a second, sorry about that.
Got it. I got it. Yeah. So we did really haven't seen a trend there. As we try to work on writing this up, we will work on summarizing that as well.
Okay. So is there a chance that species other than rye, either a legume or a winter killed cover crop, could increase nitrate leaching?
That's a good question. I don't have any specific data on that. I don't think that the winter grass, winter killed grass like an oat would increase it, but I think should be careful because I don't have my own data on that, and I can't remember. There's been some work, I think, at Southern Illinois University, and there may have been a little bit of a potential for some increase with a legume, but I would need to look at that a little bit more. And it reminds me, it'd be nice to get somebody from Illinois, they've done some cover crop work there with their nutrient research and the Illinois Nutrient Research and Education Council on cover crop. That'd be good to get, because I think they've used some, they've had a little more success with getting mixes that have grown.
Okay. Were there any differences in concentrations at base flow compared to storm flow?
That's a great question. And actually I was thinking about that this morning. That's one of those things that we need to see. What I would say is, in general, if we have drain flow, I can talk about that from like our drainage water quality sites, that we've looked at that like under high flow conditions or lower flow conditions, and there's not a strong influence on increasing or decreasing nitrate concentration. If we're getting drain flow, we'll see nitrate. What you will see though at some of the watershed sites is if we start to get surface runoff, then you'll start to see a dip in nitrate concentration because that surface runoff water is lower in nitrate. But we do need to start looking, a little bit more at some of the, the temporal variability, see if we see any, greater differences in nitrate concentration during certain times of the year where we have the cover crop planted.
Okay, so did you look at their nitrogen or nutrient fertilization decisions in those watersheds where there was increased N applied that might be partially responsible for the not so great huge reductions? Did we look at that, Matt?
No, well, we do have some of that information because so and I don't think there was much of a change throughout the years. So at least for the treatment watersheds, we have fairly good information about their nutrient management practices, and those didn't change a lot or change much throughout the monitoring period.
Okay, so did you is there analysis of cover crops versus other management practices in terms of nutrient reduction, in terms of cost effectiveness? In those watersheds, they also did put some no-till in, right?
They did put some no-till. Yes. Yep. They did put some no-till, and I guess one of the things I would say is from a from a nitrate reduction standpoint, as we look at some of the meta-analysis that have been done out there, and we combine some of our Nashua and Gilmore City, long term, I wouldn't expect a reduction, a consistent reduction in nitrate with the no-till. So at least in this one, the practice that was uniformly implemented that we would expect to have a nitrate reduction benefit would be cover crops. And we didn't look, as part of this study, we didn't look at, say the cost effectiveness of cover crops versus, if we had implemented a bioreactor or something like that. This was just, can we document what happens if we use cover crop? Well, if we use infield management and cover crops were the main thing.
Well, Matt, because the wetland was there, that's why we did.
The wetland was already there, yes, and and all those wetlands are functioning very well for nitrate reduction. Yeah.
Okay, so all right, so here's a question. So more cover crop growth means more nitrate loss reduction, but if the cover crop amount is before corn and it impacts the yields, should we be paying more for them to put that cover crop in to get more growth to possibly offset potential cover crop yield? And maybe another thing is, do we need to change what maturity of, what type of corn we're planting if cover crops are so important for water quality?
Yeah, so that's a good question, and we could also look at it. We still have a long way to go with cover crops, so maybe we prioritize doing it before soybeans where we get greater growth. I do think that with the corn, it can be a little bit of a challenge. Although I think people are seeing, with good management of the cover crop, they can reduce that potential yield impact. But, I did say we want as much biomass as we can, but we want as much biomass as we can without negatively impacting the corn crop. But it is something, as we heard at one of our R&Rs, one landowner was planting a slightly shorter season corn crop. That could be beneficial on both sides. You might not plant it as early, or you might be able to harvest it a little bit earlier in the fall so that you have more opportunity for fall growth of that cover crop as well. And so, maybe there's, I don't know if there could be programs that could offset that, but maybe something to think about.
Okay, so Matt, somebody's calling you out because you did the extension typical or the ISU researcher typical, which is, you said something was likely to happen, and that we often get caught in these gray terms like may or possibly, which shows uncertainty, and farmers don't respond well to uncertainty. So would you just come right out and say that there was a reduction?
Well, I want to know, because I do want to analyze that. I think we need to do some statistical analysis to feel comfortable. We have looked at, I will say, from our Gilmore City, there was a statistically significant difference in the first and second 5-year period when we had the tillage, and there was in the second 5-year period where we had the no-till versus the no-till with rye. But I think that, I probably in some ways should have waited till we got some of the statistical analysis done to maybe talk about the Watershed study, but that's something we need to look at for sure. So yeah, I will.
So you don't want people to walk away from this saying that, cover crops aren't making a difference because on these small watershed delivery level, we're not seeing it.
No, I think when I talked about this 2 years ago, it was a little more discouraging, right? Because the first 3 years, we really didn't see any change compared to the pre-implementation. The last 2 years, I think are encouraging that we might be, seeing some. Now, this is where actually Dr. Crumpton and I talked on Monday, like, okay, well, if we get a third year, what's it, if we get another year this year, so then we'd have 6 years post implementation. What's it gonna show us? But I'm encouraged, but I need to get a little more analysis done.
And I'm going to pipe in here. This is a good example of why having these long-term research situations on farmers' land as well as plots is really important. So long-term monitoring is essential, but also long-term, like the conservation learning labs, having this small scale watershed.
Agreed.
Okay, so here's another, there's still a lot of questions. Your data seems to indicate that the benefit is from the change in the form of nitrogen, nitrate versus organic nitrogen in the plant, rather than any change in water via evapotranspir. I can never say that word.
Oh, yeah. Okay. So that, what we see really at all of our sites is a reduction, in the nitrate nitrogen concentration. I think that what this is getting at is that with the, we're not seeing a reduction in water flow with the cover crop. And that is true. We, at our drainage plots, we've not really been able to detect a change in drain flow with or without a cover crop. Now, that's kind of consistent with a lot of other studies. There was a study that Jeff Strock did in near Lamberton, Minnesota, where they saw a reduction in drain flow. But most of the others, really what we see is a change in the concentration of nitrate leaving the plant root zone, not the amount of water. And the way, as we've done some work with soil water content monitoring. And what we've seen is that we actually did it at Gilmore City and in Ames. And what we saw was that at Ames, we would see a little bit of a reduction in soil water content when the cover crops were growing, because we were really getting really good cover crop growth. But then when we killed that, we would have a little bit of a mulching effect. And so, when we had the cover crop growing, we probably increased transpiration a little bit. But when we had that mulching effect, we would reduce some of that evaporation off the soil surface. So I think that's the way I've been able to reason in my mind why we haven't seen, why we've not been able to see much of a change in drain flow. Somebody commented to me here that this may be some of the first truly watershed scale assessment of the cover crop effectiveness. And I think that's fairly accurate.
Okay, Matt, somebody is helping you out here on the question about legumes, cover crops, and whether they can increase leaching. There's a 2018 publication by Thapa et al. That shows a meta-analysis confident intervals for legume cover crops and mixtures do show no consistent change in mean leaching.
Mean leaching, okay.
All right, so don't you love it when your audience helps you out?
Thank you. Thank you, Nick. Oh, sorry.
Yeah, well, all right. So we got another question here that was wondering if we have extended rotations, such as in an organic system. Do you think that would help? What do you think the impact would be in that, or even adding cover crops to an organic rotation where there might be a little change?
So, I'm going to use I want to be careful because I want to give an answer, not give the extension answer, right? But I think that I think if we have something from a nitrate perspective, if we can increase the amount of time that we have green cover, living roots on the land, we have the potential, strong potential, the research would show we can decrease nitrate leaching. So, Dr. Liebman's work on the Marsden plots of long-term rotation, they see a reduction in nitrate leaching when we have, corn, soybean, oats, and clover. So because we're going to have something growing on that land a greater percent of the year. That's a great question about the organic system. And in fact, I think that we should appreciate that comment. I'm not going to hazard to say exactly what the water quality impacts would be, but I think that would be a good webinar topic. And there's been some work done by the National Lab for Ag and the Environment and Kathleen Dellett on some organic plots, subsurface drained organic plots here outside of Ames. So that would be a great webinar topic for the future to specifically look at thinking about an organic system there.
Okay, would increases in soil porosity, is that how you say that?
Porosity.
Porosity
Yep.
with cover crops have compromised nitrate capture? And would this explain instances where the effect seems reduced? Well, it looks like we stumped the expert.
Yeah. Okay, say that again.
Would increases in soil porosity with cover crops have compromised nitrate capture? And would this explain instances where the effect seems reduced?
So I don't think so. I mean, if we do get increased porosity, we're going to get greater infiltration. I mean, some of it would somewhat depend if we had short circuiting of water flow in there with a lot more macropore flow, such that we didn't get, a lot of maybe interaction within the plant root zone. But might have to think about that one a little bit. I don't think so, but yeah, that one might have stumped me. Not very good. Yeah, that somebody said enhanced preferential flow might be less time in the root zone. That is what I'm thinking. The only thing is that we can get a fair bit of preferential flow, but I don't know what happens then when that water moves kind of through the saturated zone to get to the tile. So there would be some preferential flow right to the tile, but then a lot would be just maybe preferential flow right to the saturated zone.
So Matt, I'm going to throw out there too on the cover crops. Obviously, we're talking specifically about nutrient reducing nitrate, but cover crops have a lot of other benefits. So beyond the water.
Absolutely. Yes. I mean, we're protecting the soil surface. We are going to add some organic matter back in there. And so, and
so we definitely see a reduction in erosion, sediment movement.
Protecting this. Yeah.
Okay. So
and may serve as a forage source or, other feedstock. So
yeah. And just one other maybe
weed suppression. We heard. Yeah.
Weed suppression.
Sorry.
Well, that's what I was going to say is we just heard from farmers up in the northeast corner of the state who now have cover crops from 10 to 20 years that they are seeing all sorts of things. So I'd be curious to see what we'd see on these CLLs if we can keep those, if we can have those farmers keep those cover crops there so we can look at them another 5 years from now.
Yeah.
To see what we really see then. I think maybe the message of your talk is that this takes time.
I think it does take time, and I would say it takes time. And I do think there's the importance of trying to do as I show here, long-term monitoring, because a 2 or 3 year study may not give us a full picture into what might be happening in these dynamic systems.
And it takes time, which means if you don't start, you're never going to get there.
There we go. That's right.
All right. Well, Matt, thank you very much. That's all the questions we have. You want to put our commercial up again?
Oh, yeah.
And I'll let you make the commercial.
Yep. Okay. So one, if you need CCA, Elena Whitaker, ALENAW at iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. And this one, again, iowalearningfarms.org/survey. If you would be so gracious as to fill out the voluntary demographic survey. And lastly, tune in next week. I should be back in my more comfortable chair as the host for Mapping Evapotranspiration at the Field Scale by Dr. Antonio Arenas. So thanks everybody for joining today. And thank you, Dr. Comito, for somebody said they like this game of Stump the Expert. So, yeah.
Okay. So yeah.
Okay. Thanks a lot, everybody.
Thanks everyone for joining us. Don't forget to turn off recording.